Okay guys, example number 2. We have a different type of log graph, and what's special about this is that it's been transformed. So it's basically been shifted from its original equation. So first of all, by looking at this, the first question says, state any limitations for the x values. So looking at the x value, what we can see here is that along this graph, from the back of 3, there are no x values. So there's no graph whatsoever happening at the back. But from here onwards, the graph exists. So when x is 4, the graph exists. When x is 5, the graph exists. When x is 3.5, the graph exists. But does the graph exist at 3? Obviously not, because there's an asymptote. So we can say the graph does exist, okay, when x is greater than 3. Yeah? So we say x is greater than 3. That's when the graph exists. Now we want to state the equation of the asymptote. You can see the asymptote cuts through number 3 at the x-axis. So your asymptote is x equals 3. Now we want to describe the transformation that occurred. Originally, the asymptote should be at the x-axis, yeah? But because it's been shifted 1, 2, 3 units to the right, so we say it has been shifted 3 units to the right. Okay, and we can really see that here. Yeah, now looking at this +1, it tells us the whole graph has been shifted up level. So think of it as an elevator. Yeah, so an elevator is being shifted up 1. So we say shifted up 1 unit. And that's the answer for part C. For part D, what are the x and y intercepts? So looking at this, we can kind of see that the x-intercept is not really a whole number. So when we want to find an x-intercept, we usually make y equals to 0. So let's substitute it into this equation. So we have y equals to 0 log base 2 x minus 3 plus 1. Now let's do our algebra. We want to know that there are 2 terms. That's 1 term, 2 terms. We're going to bring this term over first because x is kind of stuck in the first term. Yeah, so we have minus 1 equals to log base 2 x minus 3. Okay, sometimes it's a bit unusual to see in this format. So if you're uncomfortable with this, we can just swap it around. But everything stays the same. So my log here is basically here. Minus 1 is here. Same thing. Okay, we know from the previous exercise that we can bump up the number 2. Yeah? So what we have left is x minus 3. The log disappears. We have 2 to the power of minus 1. You can put that into your calculator, 2 to the power of minus 1, which is the same thing as 1 over 2. Yeah? You want to solve for x, so we bring over the minus 3. It becomes a positive 3. So half plus 3 is basically 3.5. And that there, my friends, is the x-intercept, 3.5. Now, we want to find the y-intercept. Clearly looking at this, it doesn't cut through anywhere. So we say, therefore, y-intercept, there's no y-intercept. And that's the answer for part D.